So hello everyone. This is the kickoff presentation for the Cartesi Experiment Week. We were hoping to make it quick so we can all get to hacking. We'll start off with this is the agenda. So we're gonna have a few presentations really quick about the ecosystem, the structure of the foundation. And then we'll move on to presenting the actual experiment week, though we have sent a lot of messages about it already, so I think everyone is up to date. And then we'll have some presentations about the technical aspects of using Cartesi, which we are all excited to see. So the developer advocacy unit volunteered to give us a presentation. And then we're gonna have a DRAN demo, which is one of the CGP projects that implemented a random number generator using DRAN for Cartesi. The Negro, which is a cool Go framework that Linneo was preparing. And then Claudio asked for a regular mic to talk about the tiny mic. And then we get to hacking. So if everyone's ready, I think we can start. Yeah. All right. Oh, sorry, that lost me. So I think I'll pass on the mic to Brandon, so he can help us understand a little bit the ecosystem.
Yep, thanks Felipe. Welcome everyone. Super excited for Cartesi Experiment Week. And I think that this week is a week of experimentation, but also the week itself is going to be an experiment for all of us too. So let's let's see how it goes. Thought we could just kick off with a super quick overview of the Cartesi ecosystem. I know that there's been a lot of change, a lot of shuffling in the ecosystem for everyone. So I thought it might be helpful to just tick through real quick how all the pieces fit together. I don't have access to switching the slides. Can I ask for next slide? Yep. Oh, so the ecosystem sort of broadly is broken down into a couple different categories. I think we can generally think of it as core units, core companies, DApp builders, rollup validators, community members, and then the Cartesi Foundation. Next slide. Yep. So I think the central piece is sort of these core units, right? So what is a core unit? These are autonomous, self-coordinating teams that contribute based on domain-specific subject matter and expertise. I think we generally think of core units as sort of divided between technical and non-technical. So on the technical side, we have research, node, rollups, Nother, the Cartesi machine, compute, prototyping, and tech coordination. And then the non-technical units we generally think of as developer advocacy and ecosystem growth. The next category would be core companies, right? So alongside these units, the core units, we have a number of development companies, agencies, and other companies that are working alongside the units to build the tech and provide services. So I think examples of core companies would be companies like Sunodo, Zippy, UX Boost, Productive, and then Noir and Serotonin, which do branding and marketing. Next slide. So the next category of contributors in the ecosystem would be the DApp builders, right? So these are sort of the technology's reason for being. rolluplab.io, which some of our contributors are working on a revamped website there, is the Cartesi community's repository for proof of concepts, hackathon projects, and other experimental apps that are being built with Cartesi Rollups. Next category of contributors in the ecosystem would be our rollups validators. So we have Sunodo, which is a sort of rollups as a service business that plans to provide hosted validation services to ensure honest execution. And then, of course, as the fraud-proof system matures, we'll have a growing network of self-hosted provers that will work alongside Sunodo and other RAS services to secure the validity of Cartesi DApps. And then of course community members, right? So I think we can think of all of the contributors that I just mentioned, the core units, the core companies, the DApp builders. These are all community members, but community members are much broader, right? So we have community members around the world. We're hosting meetups, workshops, and other initiatives to help grow the project's global footprint. And we currently have community ambassadors building grassroots support on every continent that has permanent habitation. So I guess Antarctica, we're still waiting on a community ambassador there. And I'll pass it over to Colin for an overview of the Cartesi Foundation.
Sure, thanks, Brandon. So welcome all. Super excited about launching this hackathon and seeing all of the projects and ideas that everyone comes up with. So you just had an amazing overview of the ecosystem that Brandon did, and we thought it would also be a good idea to introduce the structure of the Cartesi Foundation directly quickly. So next slide, yeah. So the foundation is made up of a board of directors who are myself, Brandon Isaacson, Eric Tamora, and Karsten Monk, and Felipe Argento as an advisor to the board. The foundation primarily carries out 4 duties as a contributor in the whole Cartesi ecosystem and has 2 respective departments, which are finance and marketing, to help carry these out. So these 4 things are admin, which involves hosting ecosystem platforms and legal entities for fiat holdings and entering into real-world contracts. Advice for all ecosystem grantees towards fostering development and adoption of Cartesi's technology, and as a steward for early governance systems that are formed. Allocation, which means issuing all of the grants that are present in the ecosystem and engaging vendors at grantees' requests. Also funding other initiatives like events, hackathons, meetups, educational programs, and community-run programs like the CGP. And the final main task of the foundation is amplification, where our marketing team is working around the clock to advocate the technology and vision, celebrate the progress, spotlight builders in the ecosystem, publicize events, and bring visibility to everything that's happening. So these are kind of the 4 main contributions of what's happening as a contributor to the Cartesi ecosystem. So any questions at any time of what the foundation is doing, please feel free to reach us out. So we can advance to the next slide, Philippe. And I'll hand it over to whoever wants to start the experiment week introduction.
Sure. So you finished your talking about celebration, and I guess the experiment week is a celebration of us finally reaching mainnet ready. So Honeypot is live, which is super exciting. It's already listed on all Bits. And then we thought that it would be a super cool idea to have this experiment week for us to finally stop breathing a little bit, figure out what we built and what it is for, and figure out what are the next steps, right? And as many of us have been saying for years, the best way to figure out the next step is to eat your own dog food, right? Play with the tech, figure out what is missing, what can be improved. So this experiment week is an invitation for us all to interact with the thing that we built, right? Because the value of the tech is not on the abstract. The value of the tech is in the concrete use of it. So let's try stuff out. It's gonna be a week-long hackathon, and hackathon is in quotes because a lot of the times hackathons are associated with pulling out all-nighters and eating pizza and Red Bull. We don't expect anyone to work themselves to death during this week. So that's why it's in quotes. It's just basically, instead of focusing on the previous task that you were doing, we now focus on exploring and experimenting and having fun and building all sorts of cool stuff, right? So, and this includes novel DApp ideas. If you have something that you want to try out, this includes tooling. So if you think there's something that is hindering development, or it's something very hard for developers to tackle, maybe you can build some tooling to help out, right? So improvements, tooling, anything Cartesi-centric concept, any Cartesi-centric concept is super cool. Recently, I was watching an interview with a guy from marketing on Red Bull marketing, and he said something that really resonated with me. He said that Red Bull marketing wants you to discover their product in an awesome way, in a cool way. And I think this hackathon is also about that, right? It's for us to create these concepts and apps and ideas so people can discover Cartesi in a cool way. So right, like discover Cartesi by playing Doom on on their browser, or discover Cartesi by using this kick-ass application instead of like having to read about the technical aspect of it. So the hackathon has a few goals, right? There's a goal of us experimenting and learning about our own tech. There's a goal of us figuring out what we really need to add to the roadmap. What is the next thing that we need to build? Because I have a feeling that our roadmap is very much technically focused, but not necessarily tackling the right priorities, right? So say like, why do we need to optimize gas that much instead of building the thing that actually hinders the adoption, right? So it's a invitation for us all to reconsider the roadmap. It's also an invitation for us to build cool shit, things that can bring a spotlight to Cartesi, right, in the macro context, and then make us stand out and have people come to build with us as well. Because we also we have this goal of increasing the amount of people building with Cartesi or building Cartesi as well. So these are I guess, the main goals. If anyone else wants to say something, I can pass the mic, or I'll go to the bureaucratic explanation. Anyone?
I think that's great. I'll just add that Cartesi is all about opening up the design space to new possibilities, and I think the people here and the people who are hanging out with us on Discord are very good candidates to come up with these new ideas. So adding to what you said before, I think that's a good point as well.
Definitely agreed. All right, so we're kickstarting it right now, and then we'll have on October 22nd, we'll have a submission and presentation, right? So there's a form here. We'll circulate that link because I guess you guys cannot click on the presentation, but it's a tiny form for you to submit your presentation by 12 p.m. UTC on October 22, and we'll have a presentation session, 2 to 4 minutes. It's gonna be on a community call on October 23rd. So, like, we are being super flexible with this because, as Brandon said before, it's all an experiment. We are also experimenting the format of the hackathon. You guys are experimenting the tech. We are also experimenting the tech because we're also gonna hack, though I don't think we'll be able to participate in the prize pool. So we're being very flexible with everything. The only rule about the presentation is that we require basic slides, right? But even like, if you don't want to have basic slides, you can shoot us a message and you can negotiate. The idea is that the presentation should be done regardless of the project working out or not. So some people are gonna plan to build things and they're gonna fail to do that, and that's also very important, right? Because the failure also gives us a lot of information. So please don't be shy. This is not a competition. This is all collaborative. So yeah. So and for those participating in the ETH online hackathon, which is super fun, they have their own rules. So make sure to keep up with that. And I think that's it. I think you can move on to the workshop, DApp workshop. Payal, Jatin, come up. Nice. All right, passing the ball to you.
Hello everyone. Thank you for joining us today. I can't seem to find an option to share my screen.
Oh, I think I have to stop sharing it. Can you find it now?
Yes. Thank you so much. Yeah. So, can you see my screen?
Yeah.
Okay. Thank you. So yeah, I'm super excited to be presenting Cartesi's technology for this experimental week. So I'll just give a brief introduction of how Cartesi is scaling Ethereum ecosystem, and then I'll introduce how to set up Cartesi environment, and I will also build a simple DApp so that we get a hands-on kind of a feeling. So as we all know, Cartesi is application-specific rollup for Ethereum compatible chains with a Linux runtime. So Ethereum, as an inherent problem with greater adoption, Ethereum has faced congestion and scalability issues. So one of the possible solution is to offload the computation onto off-chain VMs. So Cartesi has created a unique virtual machine which is deterministic, self-contained, and also reproducible. So what does this do? This provides you with unbound computational capacity for your particular application. And since we have ported Linux to it, it provides programmability, which allows a Web 2 development experience for developing Web 3D apps. So any developer who is proficient in Web 2 tools can utilize Cartesi to start building Web 3D apps. So what Cartesi has done in a nutshell is that it has separated the execution layer from the data availability layer and the verification layer. For example, the Cartesi Rollups framework executes all the off-chain computation, and it depends on the underlying blockchain, which may be any EVM compatible chain, for the data availability and also for reaching a consensus through a dispute resolution protocol. So this is a brief overview of what the architecture of Cartesi looks like. We have the Cartesi Rollups framework, we have an underlying blockchain, and we also have some front-end tools to interact with. We expose GraphQL API and HTTP API for advancing and inspecting the state of Cartesi machine. So the rollups is an infrastructure which makes the Cartesi virtual machine talk to the EVM compatible chains. So it contains of two components. One is the on-chain components, which is nothing but the smart contracts, which allow the Cartesi DApp to actually get data and manage assets and data on-chain. There are also several off-chain components. We might not get into this right now. They are components which allow functioning of Cartesi virtual machine in a Ethereum environment. So yeah, let's jump to building a DApp. So I will be using Sunodo today. I will also be sharing a link which you guys can use. Follow things. Can I? So I've pasted this link in chat for your reference so that you can keep pace with the presentation. So we need to have the following components. We need to have Node.js, Yarn, Docker desktop, and we need to have QEMU support. We also need Foundry Forge. I will not be getting into the installation details, but you can find the list of requirements in the link that I have shared. On the Windows, you should have WSL2 installed to get it up and running. And you should also install Sunodo framework, which can be installed using npm as a package. Yeah.
Is there an issue with his laptop or something?
Yeah, I think it froze. Oh, it dropped. Let's give him some time to come back. But I didn't know about this workshop repository. That's quite cool. I was trying to install D-roll and Zenodo by myself. I was having some trouble with it. Yeah, Bruno. Zenodo is airtight. Maybe we can jump to the next demo and then come back. What do you guys think?
Yeah, that's a good idea.
All right. So next in line we have, I lost it. Linneo, egg roll demo, a Go framework for Cartesi. Hello.
Yeah, let me share. Oh,
By the way, thank you for everyone that volunteered to give a presentation. That's super cool. So thank you, Linneo.
no problem. I'm not able to share my screen for some reason.
Oh, yeah, me neither actually. I think maybe he dropped the screen sharing on. And Discord.
We found a bug in Discord. Nice.
Diego must be happy in the audience. Well, anyone has access to the source code can figure out, patch it. I'm creating a Google meeting, and I can share the link in the chat. Then maybe you can do a screen there, and then we'll come back to Discord. Oh, he's back.
I think Jathan is back. Yeah.
Oh, nice. Okay, sorry, Lino. He'll come back in 5.
Did you guys? Sorry for that. So yeah, we have this deployed, like it's running. We can check this out. So it exposes a GraphQL API, and it also exposes an inspect API, HTTP API endpoint. So the node is up and running. But for prototyping, we will not be doing it in production mode. We will be prototyping with host mode, where we will not be actually running the backend inside a Cartesi machine, but we will be emulating things just for prototyping, since it will be much simpler. So we can enable the host mode by using a simple command. So now we are running in host mode. or maybe just let's just run it in a production mode for now. So the only way to interact with the Cartesi machine is through the inspect state and handle state requests, where inspect state is something which just allows you to get the state of the machine, and the handle advanced state allows you to advance the state of the machine. So let's create some reports and notices and vouchers, since notice, report, and vouchers are the main elements of a Cartesi DApp, which allows it to communicate with the underlying blockchain. So, So the idea here is to create a voucher when we send a message called, which is hex code for the text voucher. So we want to create some vouchers using this, and we can also create some notices. Notices are nothing but they are just on-chain data which can be verifiable using proofs, and vouchers are remote function calls for smart contract functions which can be called from inside the Cartesi DApps. Vouchers are an integral part of a DApp, since in order to manage the assets, for example, withdrawing ERC20 tokens or ERC721 tokens, you need to use vouchers. We need to build this again. So let's just deploy a simple contract, the storage contract to emulate the voucher functionality, and we can get the ABI using Remix. This is connected to the local hard hat node, Foundry node. Very. You can see that it was deployed at this address. I'll just also quickly go through how we interact with these DApps. But we need to build this again. Generally, we expose a GraphQL API where, in order to query the vouchers, notices, inputs, you can use Postman or you can use a custom front end to keep interacting with the Cartesi DApp. It is exposed at the GraphQL 8080 endpoint, and these are the format of queries. All of this is documented very well on the Cartesi docs. I'll showcase this functionality. Take some time. Or maybe just let's look at the interaction part. As you can see, there are no notices yet and no vouchers yet. In order to send an input, we can use the sudo send command, and we can send the DApp address. As you can see, we have sent a request to the relayer smart contract, which relays the address of the smart contract. You can also send some generic inputs. Let's send. So we can, we also have a explorer where you can list out all these inputs. As you can see, we have these recorded inputs. First one was sent to the DApp address relay, as I mentioned, to send the address of the DApp. And we also send a generic input to the DApp. You can use Postman also to list the inputs. You can use different tools. We can also get into notices and vouchers, but I think I'll just call it a day and maybe explain. So yeah, you can prototype with host mode. The advantage is that you don't have to cross-compile everything, and you can emulate things while locally running the Cartesi DApp on your machine. So there are only two ways we can interact with the Cartesi machine. One is the inspect state and the advanced state. Inspect state is through the inspect endpoint, and it is a HTTP endpoint. You can do that with curl or any other method, whereas the GraphQL endpoint exposes different vouchers, notices. Yeah, so I'll maybe finish things off with a few ideas for inspiration for building during the hackathon. So I think Cartesi is very well suited for machine learning and DeFi and IoT applications. We had one of our hackathon winners integrate Alpaca, which is an LLM, directly onto Cartesi, which opens up a whole new avenue of applications where you can have decentralized AI models or decentralized machine learning models, which totally limit its capability for misinformation and biased training. You can also use OpenCV. We have successfully demonstrated OpenCV based applications for identifying fake fingerprints. So it's a very interesting application. And Doom was a showstopper in Eat New York, where our team demonstrated the power of Doom on Cartesi and was among the finalists. So you can have fully on-chain gaming like Ultra Chess and Dazzle. You can build different games on Cartesi. And for DeFi applications, we need huge amounts of computational power, which is not possible on Ethereum natively. For example, in Nucleus, they had done completely on-chain risk analysis using different variables. So it was quite complex computation. So you can have verifiable risk analysis or decentralized risk analysis using Cartesi. And you can also integrate IoT sensors. For example, onboard diagnostic data from cars was integrated into a Cartesi machine to get the driver profile and give out insurances depending upon how the driver's profile is. So you can also integrate games and AI, not just games and AI separately, but together also, where you can have bot versus bot fights and even bot versus human fights. You can also have complex computations like the Mandelbrot generative AI images, which is a very computationally intensive task. We've also had people integrate GeoJSON library and SQLite to give automated parking tickets to people using a decentralized parking app. Yeah, happy building, guys. I hope this gave you an overview of how it is to build on Cartesi. And yeah.
Awesome. Thank you, man.
Thank you for having me.
So let's go to Linnell and can you share the screen now? Oh, I think Jatan needs to stop sharing, please. So Linnell can.
Hello, everyone. So I'm Gabriel from the Node Reference Unit. And the last few weeks, I have been working on a high-level framework in Golang to use the Cartesi technology. So the idea of this framework is to provide abstractions for all these APIs and everything that the developer needs to know when using Cartesi. And in Negro, I want to provide abstractions both for the contract part, which some people call the DApp backend, and for the client part, which some people call the front end. This is the documentation site that I'm working with. So, but I'm going to show just code because I'm going to get straight to the point. So this is the template of a Grow project. This is based on a Sunodo template, and I want to merge it to the Sunodo templates eventually when it's more stable. And in the template, we have a bunch of files required by Sunodo, but the most important thing is the client and the contract. So the contract is the DApp that runs inside the Cartesi machine. In this case of the template, this is just a very simple contract, and it just echoes the input received by the advance. So here's the advance method. So sorry, the first step is to define the contract struct, and this struct should implement the advance method. So here in the advance method, we get the input that was sent by the client, we log it, so we just print the message, and then we send this input back. And then in the main function, you just call the roll function to pass in the contract, and this will start the rollups and everything under the hood. So you don't have to worry about any APIs, everything is just Go code. And here's the Docker file for the Sunodo. This is taken from the Sunodo Go template. The only line that is important here is the Go build. So this builds the whole application and puts it inside the RISC-V machine. So you don't have to worry about this, you just need to copy the Docker file. And then on the outside, you can just create, so this outside is the client, which is running off-chain. And this interacts with the Cartesi Rollups node and the Ethereum node to send inputs. But I also provide abstractions for this side as well. So we create, in this first function, we create a client and a signer to sign transactions. In this is a dev client because the signer will use mnemonics to sign the transactions. So we send the input here. This is just input that came from the command line. And then we send, and then we wait for the result, the advanced result, and then we print this result. So let me share my terminal. So in this terminal, you can see I already ran Sonodo build and Sonodo run. This build the application, and then I start running the application. And as you can see, it starts the Cartesi machine and starts running. I did that previously to save time. And then in another terminal, we can just run the client. So this is the same client that I was showing. And if you pass the hello, internally it's sending the input to Ethereum, getting the output from the Rollups node, waiting for it to be ready, and eventually it shows up the output that the advanced method sent. And as we can see here in the Rollups terminal, it received the relo and processed everything correctly and sent it back to the client off-chain. Let's go back. So this was a very simple example, and as you can see, it's for simple examples, it's simple to define stuff. So I am adding a few features to Agro as besides this simple example. One of these features is integration testing. So we can define integration testing using Sonodo, and in this case, it tests the template that we just saw. It creates the integration tester. This will start Sonodo under the hood, and then we can just do the same thing with that we did in the client. We create the dev client, we send the input. Now I'm checking for errors. Previously I wasn't, but this is the correct way to do. And I'm waiting for the input to be processed and getting the result. Then I'm checking if the result is the one that I sent. So here in line 26, I sent a row, I got a row back. And I'm also getting the logs from the DApp. So if we check here on line 13, I'm sending a log on inside the Cartesi machine, and I can easily recover it using aggro outside with the logs method here from the result. And it checks the log as well, and it is what I'm expecting. So this is the test. So another feature that I'm working on that is available is the codex. So we might want to send more than bytes to the DApp and receive more than bytes, because it's really cumbersome to just send a binary payload. So the codex allows you to encode and decode values automatically. So in this case, we have a text box example. In the text box, we have a string value that's on the blockchain. And we can send two kinds of inputs. We can send append input that adds to the text box, and a clear input that clears the text box. And this is just an example to show the codex. So here we are defining those types and defining the codecs for those types. And here we are defining the JSON codec, which is built automatically, so you don't have to write the code to wrap and unwrap those structs. Here is the contract. So this is the blockchain side. So in the blockchain side, we defined the text box contract. We add the text box inside so we can change it. We return the codecs that the contract uses. So we have to define which codecs we are going to use. And in the advanced method, we receive the input, but now we are decoding the input. So when we ask to eggroll to decode the input, it will we can do a type switch to check which kind of input we received. So if the input is a clear, we log it and we clear the text box. If it's append, we just log and then we append the string to the text box. And if none of the above, probably someone sent invalid input, so we reject it. And in the end, we return the state of the text box as the result of the advance. So here is a quick demo of, not a demo, but the test of this working. And in this test, we receive a list of inputs. So here on line 47, we send those inputs, just like we did before. But now these inputs will be encoded automatically by the client. We wait for the result, and then we just decode the return value, which will be a text box struct. And if it's not, it will raise an error, but it is. And then we can check the value and check if it's on the expected state. So just for you to see, in this case, this function is called if egg and roll, and then it will be appended and the expected state will be egg roll. And right after, we send a clear and a high, and we test it again, and the egg roll will be deleted, and the only string left, it will be high. Finally, I want to show off wallets. So besides the codecs, I also add the wallet support inside eggroll. So I'm going to show a simple honeypot done in eggroll. So this is the definition file that is shared among the client and the contract. We have the eggpot owner and a withdrawal input and the honeypot state, which is just the balance of the owner. And like the previous example, we defined the codecs for the input and the output. So this is the contract. The first thing is to define the contract and the codecs that we are going to use. And then we can define the advance method. So in the advance, we can either receive a deposit. So we check if it's a deposit. We call the handle deposit function. Otherwise, we call the handle inputs function, passing the input. So in the deposit case, we do a type switch as well, because we want, in this case, the honeypot only handles Ether deposits. So in the case of if it is a Ether deposit, we log it and we check if the sender isn't the honeypot owner. If it's the owner already has the assets, so we don't need to transfer. But if someone else transfers to the honeypot, we do a Ether transfer from the sender to the owner with the value of the deposits. So all the assets are in the name of the owner. And then we just return the balance in the end for the client to check. And if it's unsupported, we just reject the input because we don't know how to handle it. In the case of the input, so the owner can send deposits. Anyone, in fact, can send deposits. but just the owner can withdraw. So the first thing that we check is if the sender of the input is the owner. If it's not, we just reject the input, we ignore these inputs. But if it is, we check what kind of input it is. This is just a debug printf, sorry. And then we withdraw so we ask eggrow to withdraw the asset. This will generate a voucher automatically. And if it returns an error, it returns the error. For instance, if the owner tries to withdraw more money than it is available on the honeypot, the contract will reject the request. So the owner must ask for the correct amount. And then if it's not an error, it's just withdraw and return the remaining balance. And the get balance function just calls the balance of function for ether and return the state of the honeypot. And this state will be encoded automatically for the client. We can see this in action in this integration test. So the first steps are just to initialize the client and set the test timeout. Then we can send the inputs. So the first thing is sending the DApp address. This is required to withdraw the ether. This is by design. And then we send some ether, we send 100 way. So it receives the ether in way as integers. And then we send a withdrawal request for 50 way. Then it waits for the last input, which is the withdrawal. So all inputs are being processed on that backend, on the background. And then eventually they will be ready. So we wait for the last one. And then we decode the return, which should be the honeypot state. If it's not, it fails, but we know it is because we wrote it. And then we check the remaining balance. It will be 50, which is the input that we send, the ether that we send, minus the withdrawal that we did. And we also here in the test check if the voucher was generated correctly. So it generates the voucher with the destination, which is the DApp address, which holds the assets on chain. And then the voucher payload, which is hard coded here, but it's telling the DApp contract to send the ethers back to the owner of the honeypot. And that's all I have to show. I already have a documentation site, but it's in progress, so not everything is done here, but if you have any doubts, you can just reach me. That's it.
That's so cool, man. Congratulations. Are you gonna focus on that on the hackathon? Or are you gonna build
yeah, I'm gonna build a DApp on top of Agro, using Agro.
Nice, nice. All right, thank you for the presentation. That was super impressive.
Thanks.
Do we have someone from Kalindra at the house to give us a little presentation on DRAND? I don't see Fabio here. All right, so maybe we can jump to Claudio. Claudio asked a regular sized mic to talk about a tiny mic. So let's see how that goes. Welcome.
Hello, everybody. Let me turn on my camera. So, your friends from marketing had some ideas. Maybe you've seen the tiny microphone videos we've been doing at events over the last few months. And now that we're doing our own hackathon, I thought it would be nice to bother you guys with my tiny microphone as well. So this is a bit of a heads up. I'm going to be contacting each team, asking to schedule a 1-minute call with me. I won't be needing any more of your time than just that. So yeah, think about how you would describe your project in 1 minute, and then we'll do a short interview. Next to that, we thought it would be a good idea if all of you also, I don't know, tweet or post about your hackathon projects, and then we can retweet or just get the story going in that way. So it doesn't all just come from the marketing team. Would be nice to make it a joint effort. That's all from me. Maybe Carmen has something to add, and otherwise we can. Yes.
Hey everyone. No, I think you covered most of it. Just wanted to pop in and just add on to when you guys are sharing on Twitter, just to make sure to tag Cartesi projects so we can help retweet it and amplify it to the community. And if anyone's also submitting to ETH Global, make sure to tag them too. I know that they like retweeting stuff from builders, and it would be nice to kind of share this with the ETH Global community too.
I posted these things and handles in the chat, so you can grab them there. All right. That's all. Back to you, Felipe.
All right. Thank you. Last words? Oh, Bruno, come up here.
Hey guys, super nice to see everyone engaged in the first Cartesi hackathon. Thanks a lot for the great presentation, including all the overview and the great demos that we saw on the toolings. I'm super happy to see we developing more and more toolings to make Cartesi useful and easy to use, right? So we have been talking a lot about Cartesi and how powerful is Cartesi VM. I think now we have a great opportunity to put actions on words and make the impossible possible. We form a team with the community, with Intelli students and partial Cartesians. I think we call ourselves the Hack Masters as a humble sign of competition. But the idea that we are venting and trying to do is about creators economy and how we can engage Cartesi on creating an interesting and an automatic way to creators to build a flying wheel of value creation and sharing. We're gonna use Python. We're gonna use convenience layer of Python. We're gonna use Sunodo. And one thing that I would like to stress to everyone that is hacking in this event, please take all the possible notes on every single opportunity that we can have to improve the usability of Cartesi, right? I think DevRel has been sharing that on their reports. We also noticed that talking with community. that usability is the most important aspect of what developers says on our current stage. And Sunodo is coming to change that completely, and we know that we have a lot to do on that space. So if you guys can help us out to collect requirements and observations on that, would be super nice. Okay? And I'm very eager to hear more about use case that you guys are building. I know some crazy builders are trying to put Cartesi inside Bitcoin. Others will explore gaming, NFTs. We are in a creators economy. So happy to hear more. That's it. Thanks, Felipe, for giving the mic.
Thank you, Bruno. All right, anyone else? Well, let's get to hacking.
Yeah, I just wanted to quickly come in here as well. With blockchain, we're thinking of building a physics-based game. Details still to be somewhat defined, but if you guys if anyone is still looking for a team, wants to build some cool game, obviously like physics is something very computationally demanding. It's also a really nice fit for Cartesi. So if anyone is still looking for a team, wants to do something cool, hit me or blockchain up.
Nice. Nice. Thank you, Max. Anyone else? All right, so let's all use Discord. Don't be afraid to ask questions, give feedback, be nice. And yeah, let's do it.